Hi everyone, in this video we will be talking about the while loop. The learning objective for today is 8, write a loop whose exit depends on more than one predicate. We have already talked about Boolean predicates, and now the thing that we are adding is loops. There are different kinds of loops in Java, and today specifically we'll be talking about the while loop. Let me set you up with an example of why you might want to use a while loop. Let's suppose that you want to code a robot to be able to juggle with you. Now, juggling is going to require quite a bit of animatronics and understanding of computer vision, but let's break it down into the simplest form. I'm basically just going to throw a ball to this robot who's going to catch it and then throw it back to me. So let's think about what that would look like. How could you start to think about writing it as a while loop? The thing is, when we play with the robot and we're juggling with them, we basically just want to keep throwing the ball back and forth until the ball gets dropped. And this is why a while loop is useful. We can basically say, continue doing this action until some particular condition is met. So I'll start by creating a robot object. We've talked a little bit about objects before, and we're going to create this Boolean. I'm going to call it catch. It's a variable that changes based on some kind of computer vision. It maybe uses a sensor, and it basically tells the robot whether it has caught the ball or not. And then as long as it has caught the ball, the robot is going to be able to throw the ball back to you. Right? And then clearly there's going to be some kind of timing associated with this. All of this has been abstracted out. Right now we are just looking at this little code stub of, yeah, if I've caught it, I'm going to throw it again. If this ends up being false, let's say the robot drops the ball, so you've thrown it too far and it cannot catch, then we're just going to have the robot shake its head. Right? And that will tell you that you're out of the while loop. Just FYI, I've used bad syntax in this code. At least for Java, I cannot write this as a code stub because of some of the terms I've used. Take a moment to think about what words are not allowed for me to use. Okay, good. So catch and throw are actually Java-specific terms, and we cannot use those terms to set up variables or method names. So let's abstract out what is going on with the while loop and get a more general sense of it. We're motivated by this idea of wanting to code a robot to throw a ball back and forth to us, but what does the syntax look like? A while loop uses the keyword while, and then inside parentheses, you're going to have some sort of predicate, some sort of conditional statement. So as long as this is true, the thing inside the while loop will run. So that's just going to be your loop body. You'll insert whatever thing you want it is to be repeated over and over again in here. And the reason you might want to do this is programming is really about automation. You want to do something once and then never have to deal with it again. Here's another example. Let's suppose that we set I is equal to 0. I'm just going to set a while loop to say, while I is less than 100, I'm going to have it print out hello world. And then I is going to be incremented by 1. So you know that I is 0 at the first entrance into the while loop, so it'll print out hello world. And then I is 1, which is still less than 100, so it'll print out hello world, all the way up until I is equal to 99, it'll still be true. Then it's going to be a 100, and when it checks the conditional there, it will be false, so it will not go inside the while loop, and it will go to the next part. This really beats printing hello world, system.out.println hello world, and just copying and pasting that into your code 100 times. And it also makes it a lot more readable. It's a lot clearer what's going on if you try to avoid writing the same line in your code as much as is possible. Here's a picture of what the while loop is doing. So basically, when you enter the while loop, if the thing is true, it will go into whatever is inside the loop body and then come back and then check the while loop again. And as long as it's true, you're going to loop and loop and loop and loop until it becomes false, and then it'll go to whatever statements are next. So if I had some code that came after this curly brace, that's where it would go. So let's abstract out what was going on in that code just once more. We talked before about we have a while with a conditional in there, and we're going to insert our repeated statements inside the block. On top of that, you probably want some sort of setup ahead of your while loop, and then what comes after is what to do after the while loop is done. So looking back again at the Hello World code, we had it set up where we wanted I is equal to 0, so that would help us with writing our conditional inside. We have our loop body and whatever we wanted repeated, and then I don't have anything here, but there's probably either the end of the code or something else that you would want to have happen after you are done. Just to go over it in a slightly different way, the 3 steps of the while loop are to evaluate the condition in the parentheses, which yields either true or false. If the condition is false, we skip the following statements in braces and go on to whatever is next. And if the condition is true, we'll execute the statements and go back to step 1. For those of you that like the pictorial representation, here again is that flowchart. If we'll go into the while loop, we'll check a Boolean. If it's true, we'll do the statements and we'll come back and check the Boolean again. And the second that this becomes false and this Boolean evaluates to false, it will skip the rest of the braces and go on to the next part of the code. Another purpose of the learning objective is not just to be able to write the loops, but also be able to trace them. So if you see a while loop, you should be able to look inside the loop body and see what variables evaluate to. Here's an example. I have int y is equal to 0, and then y is less than 4 is the condition inside my while, and then I'm just going to increment y as y is equal to y plus 1. Now, at the very start, the first time you go into the while loop, y is equal to 0. And then from there, you'll loop, and now y is equal to 1. Loop again, y is equal to 2, and the conditional is still true. 2 is less than 4. So we can go into the while loop again. Y is 3, and y is 4. Okay, we are now at the point where y is equal to 4, and so we're going to check that while loop again, and 4 is not less than 4, so it will not do the thing inside the while loop again. We're done. And one thing to point out here as well is each time that this gets evaluated, we only go to the beginning of the while. So this part before the setup does not get looked at again. Here is another example of tracing a while loop. It's a little bit more complicated than the previous one, but this one has to do with a running total. I have int sum is equal to 0, int I is equal to 1. Then inside the while loop, I have the conditional I less than 5. I do sum is equal to sum plus I, and then I plus equals 1. So the sum is incremented by I at each iteration of the loop, and then I is incremented by 1. The question for you is, what is the value of sum after the loop? Good. So to do this, we again write our table of the iterations. And now here, I have at the start I is equal to 1, and at the first go through, after sum gets added to, it's also going to be 1. Okay, now I is 2, which is still less than 5, so sum plus I is 1 plus 2, which is going to be 3. And then again, I is equal to 3, which is less than 5. So I have sum 3 plus 3, so that's going to be 6. And then 6 plus 4, which is 10. Now, I is going to be equal to 5, which means that we're not going to go back inside the while loop again, so we're done now. And so the final value of sum is going to be 10. This example just shows what would happen for each iteration of a while loop if you have something numeric like this, and how to keep track of certain values that are getting changed within a while loop. This slide has to do with common mistakes that people make inside their while loops. So if I set sum is equal to 0, int I is equal to 1, and then in my while loop I have I is less than 10, well, that looks really similar to what we had before with the running sum. And I am incrementing my sum by I, but now there's a mistake. So what's wrong with this code? I'll let you think about it for a minute. Right, so here, notice that I don't have anything to increment I, and therefore when I is 1 and it's never changing, the conditional 1 is less than 10 is always true, and you'll end up in an infinite loop. And that's a common mistake where your code is just going to hang and you're not going to realize why exactly it's not stopping. All right, I have shown you enough examples for us to do a little bit of practice. I'll explain the problem. You should pause the video to try writing this example yourself, and then I will go over it with you. The practice for you will be to do a game called High-Low, which is a number guessing game. We're going to generate a random number from 0 to 99, inclusive. We will ask the user for a guess. If the user's guess is too high or too low, we will tell them and play again. And we'll continue playing until the user guesses the correct number. So just a couple of pieces of advice to get you started. To ask the user for a guess, we will need to use scanner. You're going to do some sort of printout with too high or too low. Here you're going to use some sort of if-else. And then to continue playing until the user guesses the correct number, this is going to look something like while guess probably not equals answer, and to have the rest of your logic inside that while loop. One more piece of advice to generate a random number. You may remember you can use math.random or you can use the random class. Either way. So now at this point, please take a pause in the video, try to write this code, and then I will go over a potential solution. Let's start to look at an answer for high-low. The first thing that we are going to do is use a scanner object so that the user can input their guesses. And we will put in a prompt which is guess a number. I'm going to have the guess be in.nextInt, so the user is going to type in their number and hit enter. And I'm going to set answer to be equal to a random number from 0 to 1, and then multiply it by 100 and then cast it to int, which will give me a number between 0 and 99 inclusive. So now let's look at our while loop. I'm going to set up while guess not equals answer, and then I'm going to do some stuff. So you'll see on the outside I kind of had to prime everything with having the user already input a guess, and also I needed to set up an answer. And so now it's just going to check that the guess is not equal to the answer. And now if the guess is greater than the answer, it will print out that it's too high. Otherwise, if the guess is less than the answer, it's going to print out that it's too low. And now at this point, the user is going to get that response, and they are going to get a chance to guess again, which is what's happening at the bottom of this loop. Now, if at this point the user guesses the correct number, it's going to go back in, and that while loop guess is going to be equal to answer. And so we're going to escape the while loop, and it's going to just print out that your guess was whatever and the answer is whatever, showing that they match. Good. So I think that this is worth taking a moment to think about how your solution may have differed. And also, this is not the best code for this kind of problem. There are some specifications that maybe you want to do a little bit differently that would make more sense. So I do want you to go ahead and think about what could potentially go wrong with this code. The next thing I want to talk about is sentinel values. A sentinel value is a value that signals the end of user input. And a sentinel loop basically just repeats until a sentinel value is seen. For the case of high-low, you could add another while loop around everything, and you could say, player, do you want to play again? If yes, then have them play again, and then if no, stop the program. So all that logic that I had on the previous slide, you can wrap in another while loop, and it would end up looking a little bit like this. String play again is yes, and if play again is not no, then go ahead and play high-low, which is everything with the guesses and the while checking for that. Good. A few more things that we should know about while loops is we do have the ability to do break and continue. We've already talked about break with switch statements, where after each case there would be a break. In the case of a while loop, a break exits the cycle. In other words, the control flow just goes outside of the end of the while loop. So before, we had while, we had some conditional in here, we have our braces, and then we have our whatever stuff is happening, maybe some other stuff is happening. And inside, if we put in a break, everything after the break is not going to get done. What's going to happen instead is it's just going to move outside and continue on into the next part of the code. I'm going to use high-low as an example, and I'm going to append the game a little bit by adding what's called a trap value. I'll explain. And let's modify our high-low code to account for this. So now, to practice using the break statement, I am going to modify the high-low game a little bit. As before, I'm going to generate a random number for the answer, and I'm also going to generate a random trap number. And if the user guesses the trap, then we will just end the game. So take a moment to modify your code that you wrote for high-low to include this guess. If guess equals trap, then just break and end the game. To have high-low have a trap value, I'm going to have int trap, which is also a random number between 0 and 99. And now I'll have that while loop again, and I'm going to have an extra if statement in there where, okay, while guess not equal to answer, if the guess is equal to the trap, then it's just going to print out that you guessed the trap and it's going to break. And so that instantly kicks you out to the bottom of the code. On the other hand, as before, if guess is greater than answer, it's just going to print out too high. And if the guess is less than the answer, it's going to print out too low. And then the user can guess again. Now, if the user guesses the trap as here, then it's just instantly going to kick him out to the bottom of the code underneath the while loop. So it'll just instantly print out your guess. You guessed the trap, your guess was whatever they guessed, which is the trap value, and the answer is whatever the actual answer was supposed to be. Another key word that is sometimes used in while loops or for loops is a continue, which is to end the current cycle and then just move to the next iteration of the loop. So similar to, it's kind of like the cousin of the break statement. So you have your while, and you have whatever your code is, you have whatever your code is. If you have a continue in here, it will not check the rest of the code, but it will take you back into the conditional check, and it will go to the next iteration on there. A lot of times you would have this within an if statement where maybe you have very complicated code coming after this continue. This is maybe very complicated, and you might want to skip it in some situations where you know it's not worth it to check. The last version of high-low that we'll play so that we can practice the continue statement is high-low with an unclear number. So instead of generating a trap number, we're going to generate an unclear number. It's called unclear, where this time it's instead of telling the user that their guess is too high or too low, we will tell them that nothing. Just they guessed unclear and they have no information about whether that number is too high or too low. So take a moment to modify your high-low code so that there's a value called unclear, and add a continue statement into your while loop to continue when the user guesses unclear. Let's look over the answer for high-low. I added something called int unclear, which is int math.random times 100, so it's again a random number between 0 and 100. And we have a while loop as before, and now I have an extra if statement, which is if guess is equal to unclear. And two things are happening here. I'm going to have to do guess is equal to in.nextInt and then continue. The rest of the code looks the same. If guess is greater than answer, print out too high. If guess is less than answer, print out too low, and then have the user be able to guess another value. Now, one thing that is kind of irritating here about the continue statement is because I have this continue, if I go here, it will automatically go back into the top of the while loop and check if guess is not equal to answer, which means the user doesn't get another chance to actually go down here for the final in.nextInt guess. That part of the code will never run because they guess an unclear value. So that requires me to add an in.nextInt statement within the continue to ensure that that actually happens, which is kind of a hassle. So you may instead think it's way easier if I just made this an if statement and then made the remainder else ifs, and that way I don't have to deal with this continue at all. It's just another conditional, so what's the big deal? And I would agree with you. In this case, continue is maybe not the best way to go about doing this. So it's really up to you whether you want to use break or continue. Almost in every instance, it's possible to use if and else instead within your while loop, and it's usually a lot easier to tell. That's not always the case. There might be some situations where you would rather use continue or break instead. That's totally up to you. In fact, there's a whole argument about it, kind of old school, which is Dijkstra says the go-to is terrible. We should have single entry and single exit with just while and then if and else. But Donald Knuth says that go-tos are sometimes clearer. And here go-to means those statements like continue or break. In fact, there is a go-to statement within Java itself, which we don't really use. So this is really a convention. It's just up to you and what you want to do with your style. And just as an aside, by the way, putting in lots of continue statements would also be similar to putting in lots of return statements within your code instead of having like the one big return at the very end. I will not dictate how you want to do this. It is up to you whether you want to use lots of ifs and else's, or if you think that continue and break would be clearer in your code. The only issue that arises is dealing with how to trace a while loop and to trace the output, because sometimes it's not super clear if you've exited the while loop or not. But that's it. That is all I have for you for the while loops, and thanks for watching.